66 million years ago, the world ended. Not with a whimper, but with a light so bright it would have blinded you from 1,000 miles away. An asteroid the size of Mount Everest punched through the Earth's crust at the Yucatan Peninsula. In that single instant, a Tuesday if you want to be poetic about it, the reign of the dinosaurs was over. But what happened right after? We know about the impact. We've seen the fire and the ash in our imaginations. But for a long time, science looked at the layer of rock marking that day, the KPG boundary, and saw a brick wall. On one side, Triceratops and T-Rex. On the other side, ferns and rats. But recent science, painstakingly drilled from the bottom of the ocean and the Badlands of North America, has filled in the blanks. And the true story of what happened right after the dinosaurs went extinct is stranger, darker, and more miraculous than any science fiction. Let's start at the bullseye, ground zero, the Chicxulub crater. For decades, researchers wondered what the recovery looked like at the exact spot where the asteroid hit. In 2016, they drilled into the peak ring of the crater, pulling up cores from the first days of the New World. The first thing you notice in the rock is horror. The impact vaporized billions of tons of limestone and gypsum. That gypsum is important. It's what keeps the world stable. When it burned, it released sulfur trioxide, turning the oceans into battery acid within hours. But here is the first plot twist. Down in the dark, scalding waters of the crater itself, something happened fast. Within just a few years, not millennia, not centuries, life came back.
Paleontologists found fossils of tiny, opportunistic little survivor called Trithyridinium eviti. Think of them as the weeds of the microbe world. While the sun was blocked and the land was poisoned, these plankton bloomed in the hot, chemically stirred soup of the crater. But if you swam there, which you couldn't because the water temperature hovered around 70 degrees Celsius, hotter than a hot tub, you wouldn't see a thriving ecosystem. You'd see an apocalyptic fever dream. The seafloor was covered in bacteria and strange phosphatic fossils. Bits of crustacean appendages, fish bones tunneled through by microbes, and coprolites, fossilized poop. Even in hell, with the heat of the melt rock beneath them boiling the water, the bottom of the food chain was trying to restart. But the land? The land was silent. To understand the true story of the extinction, you have to stop thinking like a human and start thinking like a spore. For the dinosaurs, it was the end. For the plants, it was the apocalypse. In the Hell Creek Formation of Montana, we have the best record of the before and after. Before the impact, the landscape was a jungle of flowering plants and towering trees. But in the rock layer that marks the first days of the Paleocene, the first days of our world, the pollen vanishes. For the first few months, the sky was dark. Photosynthesis shut down globally. Then came the rain. Not water. Nitric acid. The heat of the impact had fused nitrogen in the atmosphere with oxygen, creating acid rain that fell like a planetary burn victim being hosed down with alcohol. It stripped the soil bare. In the scientific journal Palynology, researchers studying the crater found something astonishing. When they looked for the first signs of terrestrial life returning, the first pollen, the first land plants, they found nothing. For exactly 200,000 years, the immediate vicinity of the crater was a biological desert. But wait, 200,000 years is a long time. That's longer than modern humans have even existed. But in a different location, at a different latitude, researchers found the first pioneer. It's not a flower. It's not a tree. It's a fern. Ferns don't rely on pollinators. They don't need sunlight to germinate the way flowers do. They release spores that can travel on the wind and lie dormant in the poisoned soil. In the rock layers dating to just a few thousand years after the asteroid, we find a fern spike. Across the globe, from New Zealand to Canada, the first green carpet to cover the graveyard of the dinosaurs was a monocrop of ferns. Imagine walking through that world. The air is muggy, high in CO2. The only sound is the rustle of ferns. No bird song, no insect buzz, just the hiss of humidity and the crunch of bones beneath your feet. The dinosaurs are still there sometimes. Their skeletons lie half buried in the mud, picked clean by the few things tough enough to survive. Perhaps the earliest mammals, scurrying like shadows. But the ferns are patient. They are the undertakers of the Mesozoic. For 100,000 years, they hold the line, slowly rebuilding the soil, slowly lowering the carbon, waiting for the next act. By 500,000 years after the impact, the handshake happened. The ferns had done their job. They had stabilized the mudslides and brought oxygen back to the soil. And now, the survivors of the Cretaceous began to stretch out. This is the Paleocene epoch, the age of recovery. When you look at the fossils from this time, specifically from the Tulloch member of the Fort Union Formation, you notice something weird. The mammals are small, really small, and scrappy. Meet Purgatorius. It looked like a squirrel with an attitude problem. Before the asteroid, mammals were rat-sized. They lived in the shadows of the giants, probably nocturnal, probably eating insects. They had simple brains and simple diets. But in the absence of the dinosaurs, evolution went into overdrive. The true story of this period isn't just mammals got bigger, it's that they got weird. The earliest hoofed animals, the condylarths, appeared. They looked like skinny raccoons with long snouts, and they are the ancestors of every cow, pig, and whale you see today. But the real victors of the post-apocalypse weren't even on the ground. They were in the air. In 2017, a fossil bird named Sidiazji abini was unearthed in New Mexico. It lived just 1 million years after the extinction. This wasn't Archaeopteryx. This was a modern bird. It had a specialized foot called semi-zygodactyly, meaning it could climb trees like a woodpecker. It ate nuts and seeds. This bird tells us something profound. The explosion of life wasn't slow. It was instantaneous, in geological terms. The moment the dinosaurs were gone, the machinery of the modern world clicked on. But don't be fooled. The Earth was still sick. While the birds were practicing their singing, the atmosphere was having panic attacks. The Paleocene was a time of hyperthermals, sudden, explosive spikes in global temperature. The worst of these, 56 million years ago, is called the PETM. The ocean temperatures rose by 5 to 8 degrees Celsius. Back in the Chicxulub crater, researchers found a layer of anoxic black shale from this period, a mud so devoid of oxygen that nothing could live on the bottom unless it was a bacteria. On land, this heat turned the world into a greenhouse. Palm trees grew in Wyoming. Crocodiles swam in the Arctic. This was the era of the disaster fauna. Since the big herbivores were gone, the survivors evolved into strange, temporary shapes. There was Berry lambda, a mammal the size of a rhino that walked like a bear but had a tiny pea-sized brain. It ate plants, but it couldn't run. It was a lumbering evolutionary experiment. And then there were the predators. Without large carnivorous mammals yet, the top dogs were birds. Gastornis, the terror bird, stood 7 feet tall. It had a beak like a hatchet. For a while, the heir to T-Rex's throne didn't have fur. It had feathers. This is the true story we miss in the movies. It wasn't a linear march from dinosaur to dog. It was a chaotic scramble. For millions of years, the planet was a low-oxygen, high-CO2 swamp ruled by giant flightless birds and possum-like creatures that would eventually, slowly, evolve into primates. So why does this matter? What happened right after the dinosaurs went extinct is the most relevant story for us right now. Look at the science. The asteroid impact created a carbon excursion, a massive jolt of CO2 and sulfur that cooked the planet. The recovery from that event took hundreds of thousands of years. The ocean didn't recover for 300,000 years. The forests didn't return to their full diversity for 700,000 years. And the mammals? They were tiny, stressed, and living in the shadow of disaster for over 1 million years. We like to think of the dinosaur extinction as a reset button, but it was a nightmare. If you were a mammal standing in the ash 100 years after the impact, you wouldn't be thinking about the future. You would be starving. The triumph of the mammals is not a story of destiny. It is a story of endurance. The survivors weren't the strongest. They weren't the smartest. They were the smallest, the hungriest, the most adaptable. They lived in burrows, ate bugs, and hid from the sun. When we look at the stars and wonder if we are alone, or when we look at our own changing climate, we should remember the story of the KPG boundary. The fossil record tells us that life is resilient. It will come back. But it also tells us that the world right after the disaster is a terrifying place. It was a world of ferns and fungus, a world of heat and acid.
A world where the only sound for 1,000 years was the wind blowing over a dead sea. That is the true story of what happened right after the dinosaurs went extinct. Not a victory march, but a narrow, desperate, and beautiful escape. And from that escape, from those tiny trembling paws and those muddy feathers, came everything we know today. From the ash, we rose.